Now let us welcome Professor DeZafra to make the concluding remarks.
So first, let me just say that it's really been an enjoyable and an impressive day with many fine talks, and I congratulate you all on your ability to present so much information within a 10-minute talk. I think that's probably the hardest of all talks to give. I'd much rather myself talk for an hour than for 10 minutes. Although I promised Sultan I won't talk for more than 45 minutes today. You asked. I guess one of the reasons for this seminar is to give you a chance to present your work to other people, to practice and have it become relatively comfortable for you to do that. And it's important, of course, because doing science without being able to communicate it to anybody else is like being a painter who never shows his paintings, or a poet who never reveals any of his poetry. So it's an important art to cultivate, and as I said, you've been doing it well. I'm struck by the fact that in many disciplines, students don't really learn how to communicate very well. And so seminars in those fields are often kind of dull, frankly. In history or English literature or whatever, it is the custom for experienced speakers to prepare everything in writing and then stand before a group and literally read it word by word by word. And that's often pretty dull. We as scientists at least have the advantage as well as the obligation to use an awful lot of graphs to make what we're talking about simpler. And I think it also makes it easier for audience to follow. That, of course, obliges you to make your graphs readable from the back of the room, to use heavy enough lines that they're not just okay for a publication page where you can get up close and look, but make sure those graphs jump out and illustrate what you want to convey to that graph, and of course keep things relatively simple for a 10-minute talk. Avoid wading too deeply into alphabet soup, saying the G alpha M is fails to be correlated to the extent that we thought with the PQZ, therefore cannot have the influence we hope to find on the ALMR. Okay, so those are all pretty obvious things, and with very rare and brief exceptions, I think none of you fell into those pits. Today, it's been a very interesting 10 years that this seminar has been going on now, because in the early days, lack of practice and preparation really showed with much more ragged presentations, and I don't think there was anybody today who would have been ashamed to get up and give a similar presentation at any sort of regular conference anywhere in the world. And that brings me also to the fact that many of you are having to speak in a language which is not your native language, and that makes it even harder. I can't imagine trying to give a 10-minute talk in Russian or Spanish or Italian or Chinese or whatever. So, yeah, congratulations. Learning how to get up and talk is only half the goal. However, you've got to know how to write as well, both to produce grant proposals that will be funded, you hope, and especially to communicate to other people in your own discipline and outside your own discipline, and even to scientists outside of atmospheric sciences. It's difficult, so keep that in mind. I was thinking, as I sat here, about a talk that was given about a month ago by a physicist called Brad Marston from Rhode Island, from Brown University in Rhode Island. He was invited to give the regular weekly physics and astronomy colloquium, and his subject was more or less the physics of climate change and the physics of atmospheres. Fortunately, many people came to that seminar, despite some apprehensions about what they might be going to hear. They came away from it absolutely fascinated and enthusiastic about the talk. First of all, Dr. Marston is a very good speaker. But secondly, his main area of interest is not and never was atmospheric physics. He's a solid state physicist. What in the world did he have to talk about in the way of atmospheric science to a group of physicists? He got into some of this work with the atmosphere because he realized in working with the equations of surface phenomena in solid state physics that he was dealing with mathematics with which, by just slight changes of viewpoint, were identical with what could be used to describe atmospheric motions, in other words, the fluid dynamics of the atmosphere. And he's published some very interesting and successful papers in that, partly because there's a slightly different and fully developed method of mathematical analysis that was useful and helped get by some problems in atmospheric studies. So, but anyway, what I really wanted to come back to was the kind of dumbfounded realization by so many in the audience that atmospheres really had physics in them. I'd kind of forgotten that myself, in the sense that it's become so familiar to me that I assumed that it was familiar to my colleagues in the physics department. The simple back of the envelope calculation about what the surface temperature of the Earth ought to be, just based on radiant input from the sun. Why is it warmer? Okay, we have an atmosphere. And then he branched off from that. Well, why does the atmosphere actually trap radiation? Well, we have a lot of water vapor, and now we're getting to have a lot of carbon dioxide. What do those particular molecules have about them that makes them close a lot of this window, which is otherwise able to transmit radiation through the atmosphere, even though it's filled with dozens of other kinds of molecular species. So how does water vapor in particular differ from all of these other species? And he went into that. Well, it's a floppy molecule with a couple of arms and so forth and so on. And these give you a lot of degrees of freedom, interaction between the vibrational and the rotational structure and so forth and so on. There are, of course, still more mysteries with water vapor that have not to this day been solved. Why does it have a whole continuum spectrum, as well as well-defined absorption or emission lines? But anyway, that kind of thing. He went through an hour's worth of the atmosphere and its physics. And why do I say this? Because, again, when you're speaking to people, even a little outside your discipline, don't assume that they know what you know. And simple advice, but I think we all forget that when talking to fellow scientists, let alone the public. And of course, that's the big problem in the future, to really make science much more intelligible to people who are not scientists, and particularly to those who have legislative power over our lives. They have been trained in law and literature and medicine and so forth, but I think even now there are only 2 physicists in Congress, perhaps. A third one has retired recently, and I don't think there are any people who are familiar with atmospheric sciences. Perhaps 1 or 2 people who've studied oceanography in their college days, and that's about it. So you're dealing with people who think in an entirely different way and are not used to accepting the rigor of science, and all they need is one loophole to say, well, you're not sure, so why should you believe it? This is a kind of or the sort of contest of eloquence that goes on between lawyers, not always based on the facts, but rather on the presentation of facts, or what can masquerade for facts, in persuading a jury to reach a conclusion they want to have reached. And I have heard reputable scientists who are on the climate denying side of the fence, along with 2 or 3 of their neighbors, fortunately not a very large number, but they use all of the tricks of lawyers and rhetorical debate to try to convince their audiences. And it's kind of interesting, if you were used to hearing or seeing any of those techniques, the way they usually do succeed in winning over an audience, and you think, how can these people sit here and accept what this person is saying? Well, it's because of the tricks of oratory, not because they have come in armed with facts, and that's the shameful side of a few people involved in the current climate debates, that they have run out of valid reasons to object, that can be rightly brought at any stage in climate science. But they have then resorted, rather than saying, okay, I was wrong, they resort now to falling back on rhetorical tricks rather than science. So anyway, I have talked long enough. I've talked for 10 minutes more, 5 minutes more than my allotted 10 minutes. And I think it's been a great day, and I hope you all enjoyed it. And we'll see many of you next year, and those of you who are making your escape into the real world sometime in the next 12 months, best of luck, and keep all the good advice you've gotten here, not from me, but from everybody in the room, including your fellow students, in mind as you go out.
So thank you, everyone. Our symposium is over now. Thank you for your